Okay, like I said, I would tell you about the alternate ending that you could do to this problem where basically everything towards the very, very end will be done the same exact way. So I've already got the first step started here, and we have a problem that says sine 2 theta equals 2 cosine squared theta. I'm just going to go back through the whole problem again in case you didn't see the other video, you didn't go to my page or anything like that. Let's talk about this. So remember, double angle, single angle, I'm trying to find it on the interval of 0 through 60. So the problem with that is that I can't solve a trigonometric function that has the angle set up with two different types. So I have a single angle and double angle, so I need to make them all single angles. So using a trigonometric identity, I get sine 2 theta is really 2 times the quantity of cosine theta, sine theta. So I go ahead and substitute that in. So from here, I'm going to go ahead and continue with that. Remember that I have a power of 2 here, and the first natural reaction would be, okay, let's solve for sine theta and that way, but divide by cosine, but then that reduces the power of the function. And I don't want to reduce the power of the function. I want to try to solve this without having to do that. So reverting back to algebra 2, let's do that whole quadratic thing. So I go ahead now, and what I'm going to do is I'm going to just solve it. So I set it equal to 0. That's the idea of when you solve the quadratic, set it equal to 0, and then you factor it and try to solve it from there. So let's go ahead and do that. So I would subtract from both sides, and I get 0 is equivalent to 2 cosine squared theta. So minus this from both sides, and I get minus 2 cosine theta sine theta. So this one's going to have a little bit of alternate ending. So here we go. I get to this problem. I notice they both have factors of 2 and cosine, 2 and a cosine, so I'm going to factor that out. So I get 0 is equivalent to 2 times cosine theta times, so cosine theta minus sine theta. So that's what it factors into, and remember when I set these things equal to 0, I can then say that they're factors because it's multiplying. The only way I can ever create 0 through multiplication is if one of those factors is 0. So now I can say that 2 cosine theta must be equivalent to 0, or cosine, okay, this is an or, okay, because they can't be at the same time, it's just one or the other, or cosine theta minus sine theta is equivalent to 0. So the way I go ahead and do these problems, so cosine theta, if I divide by 2, I here find out that cosine theta must be equivalent to 0. And cosine theta must be 0, so what theta gives me 0? And that what we find out is that when theta is equivalent to 90 degrees or 270 degrees, you will get an x-coordinate of 0. So continuing on with this. So here's the alternate ending that I was talking about. Before I went through and I solved it and I said, okay, I rewrote this as cosine theta equals sine theta. And this is the alternate ending some people might like. I'm just going to do this part intuitively. When is the only time that cosine theta equals sine theta? And that's at 45 degrees. But also, okay, we think about that as a reference angle. And if we go around the circle and we go into quadrant 2, okay, quadrant 2, the angle is 135 degrees. But when you find it 135 degrees in quadrant 2, their sides are opposite, so they're not equal then. So what I have here is that right now, I would know that theta is 45 degrees. So this is just intuitively doing this. What angles? I have my unit circle memorized. If you don't, then this probably wouldn't be the best way to do it. You would just go through and divide both sides by cosine and use the actual tangent. But I have it memorized. So I go around and intuitively think about myself, when does cosine actually equal sine? And that's 45 degrees. So in quadrant 2, it's 135, but it's negative and positive. But in quadrant 3, you find again that at 225 degrees, okay, at 225 degrees, you're going to find that, again, the signs are the same. Because in quadrant 3, x and y are both negative. So therefore, cosine and sine are negative. So at 225 degrees, the cosine of theta and the sine of theta are then going to be equivalent again. And if I go into quadrant 4, okay, quadrant 4 is when cosine is positive but sine is negative. So again, even though 45 degrees, the reference angle changes the signs. So what I'm left with is that my thetas are 90 degrees, 270, 45, and 225. So I hope this ending maybe for some of you might be a little bit better to intuitively just, look at it. So I hope that helps. All right?